Hi.
Hi.
So what do we have today?
I have an experiment called water fountain. The tools are colored water in a plastic bottle and a plastic bottle.
Okay, you can start
empty.
doing it.
Okay. First, we'll light the pen with the lighter. Then we'll try to make a hole in the bottle. Small hole.
Okay.
Then we'll fill the bottle with the colored water. But first put your finger in the hole. Then close it tightly.
Okay.
Then you will
Okay.
then you will find the bottle is not the water doesn't get out.
Why?
Because there is no air is getting in to make pressure on the water to get out from the hole.
What if I open the bottle?
The water will get out.
Can you show us now a little bit?
Like this.
Oh, so the water gets out of the bottle. Thank you. Close it. Close it. Thank you. So you said that's because of the air pressure.
Yes.
Okay. Thank you. Hi, Adam. How are you?
Hi.
So, what do we have today?
Today I will do tornado in a bottle.
So
first I have to pour water in the bottle.
Okay.
But I have it poured. Then I will add glitter to make it more clear. Some. Then I will close it with this. And I will start shaking it up to mix the glitter with the water. Then I will flip it and start shaking it in a circular motion. Then it should form.
it forms a tornado. Oh, do you know why?
Because when I shake the bottle in a circular motion, it creates water vortex, and that makes the mini tornado.
Oh, thank you. That's amazing. I like it. Thank you. Good job. Thank you. Yusuf, how are you? Oh, yeah. So what do we have today?
My experiment is called Egg Can Sing, Can Float.
Okay.
The tools are salt.
Start doing it.
Add water to the 3 cups. Then add salt in the 2nd cup. And stir it.
You will add salt also to the 3rd cup?
Yes.
Okay. Do you add the same amount to the 2nd and the 3rd cup?
Yes. Then put the egg in the here and and then put fresh water in the third cup.
Okay. So what's the difference between them?
Here the egg in the first cup sinks, and here it floats.
Okay.
In the middle.
It will be suspended in the middle.
Yes.
Yes. So the egg can sink and float. So what happened to the egg in the fresh water?
The egg in the fresh water sinks because it is more density than the fresh water.
Okay, and the second one
And,
is
it's,
it's a salty water.
So it less density than the salt water.
And we add fresh water to the third
Yes.
one to make the
Yes.
concentration less. Okay, thank you, Yusuf. Well done. Good job. Hi.
Hi.
So how are you?
I'm fine. What about you?
I'm fine. Okay. So can you show us what you have today?
My experiment is the Skittles experiment.
Okay.
My tools are Skittles, warm water, but I use hot water to make the reaction more faster.
Okay.
A plate is preferably to be white. First, I will put the Skittles in a circle around the plate, in the edge of the plate.
Okay.
And then I'll pour carefully the hot water.
Okay. Oh, we can see the colors they are forming.
Yes, the colors began to spread in the center of the plate.
Oh.
So I began to make this colorful.
Why the color spread?
The conclusion of this experiment is that the Skittles is coated in the sugar and the food coloring. So this coated it dissolves. And then it diffuse, and diffuse is meaning that to spread widely.
So it's amazing. I like its colors, by the way. Thank you. Thank you so much. Good job, Ed. My tallest girl. How are you?
I'm fine.
Okay. What do we have today?
My experiment is a lava lamp experiment. So first we're going to add water to the bottle, and then we're going to add oil. So after we add oil, the oil and the water do not mix because of two things. The oil is less dense than the water and because of how their molecules are constructed. Then we're going to add 10 drops of food coloring. So the food coloring went straight to the water because the food coloring and the water, they both have they share the same molecule.
Okay.
Then we're going to add 1 tablet of vitamin C. We're going to break it in pieces.
Okay. So what do you break it in pieces?
I don't know. So the vitamin C reacts with the water to make tiny bubbles of carbon dioxide, and these tiny bubbles of carbon dioxide react with the food coloring, the blobs of food coloring, which makes them float to the surface.
Oh.
And when the vitamin C is dissolved in the water, it's just a wave going up and above.
Okay, so can you show us? Oh, the reaction is doing, the bubbles are going up in the oil surface.
Yes.
Okay, thank you. Thank you, Zina. Good job. Thank you. Hi. How are you?
Fine, thank you.
So what do we have today?
Today we're gonna inflate a balloon.
Okay.
Okay. First,
You can help me.
pour some baking soda into balloon by using the funnel.
Okay.
Then pour some vinegar into the plastic bottle by using the other funnel.
Okay. Okay.
Put the balloon over the top of the plastic bottle. Then pour the baking soda into the plastic bottle.
Oh, what happened?
The carbon dioxide inside the balloon makes the balloon to inflate.
Okay.
Then get the balloon out of the plastic bottle carefully. And take it near to the candle.
So the light went off. Why?
Because the carbon dioxide inside the candle puts out the flame and it makes the candle to blow out.
Thank you. Good job. Thank you.
Hello.
Hello.
So I'm trying to decide. I have this substance, and I'm trying to decide whether it's a solid or liquid, and I need 2 volunteers. You can be one of them, and I need one from the audience.
Oh, I will be one of the volunteers?
Yeah.
Okay, who wants to volunteer with us? Miss Marwa, can you come join us? Yes, she needs to. She said I'm one of them.
Okay, now I need both of you to close your eyes and do as I say. And I'll take your hand and put it in this. Now, Miss Nada, I want you to touch the substance gently. Gently, no pressure.
Yes. Okay.
Okay, do you think it's solid or liquid?
I think it's liquid because my fingers go in.
Okay.
You think it's what? Liquid. I think it's liquid.
Because your fingers sink in
my
it.
fingers, yes, go through it.
Okay, now Miss Marwa, I want you to punch it hard.
Where?
Here it is. Punch it.
This is solid, I guess. It's too hard.
Okay.
Right?
Well, guess what? This is the same substance, and I didn't change anything in it.
You can open her eyes.
Yeah, you can open your eyes now. It's the same substance.
Oh, really?
What did he touch? Show me.
This.
What did he touch? This one?
Yes,
Yes.
I touched this one.
And what happened to it?
Well, the scientists called this a non-Newtonian substance because Newton stated that all liquids flow at a predictable rate.
Yeah.
But this does not follow that rule, which gives it that name. This has to do with pressure because when you apply pressure to it like you did, it acts like a solid. The grains of the cornstarch make it lock up and freeze like a solid. But then when Miss Nada touched it gently, her fingers sank into it because she did not apply a lot of pressure.
Yes, exactly. So proud of you. Great job.
I like it. So when we apply pressure, it's hard, and when we go in gently.
Gently. Try it. We need tissues. Do you have tissue? No. It's okay.
It's okay. It washes with water.
Okay. Yeah. Thank you so much. Thank you. Great job.
Okay, you said to us that's made up of?
It's made of cornstarch and water. The water has to be less than the cornstarch so that it doesn't act like a liquid.
Okay, thank you.
That's
it's
it.
amazing. Thank you. I like it so much. Thank you. So we're coming back to Ruqayya. Hi.
Hi.
So how are you?
Feeling excited.
So you're feeling excited. Me too.
Okay.
So what do we have today, Ruqayya?
So my experiment is the black snake. So before we start, I want to tell you why studying chemical reactions is important. Chemical reactions are important because they basically make up everyday household items, such as food, cleaning products, and most mainly medicine.
Okay.
Now let's start. First of all, get your bowl and fill it with sand.
Okay, you can do it.
Okay,
You can
so-
start doing it.
So it needs to be a heat resistance bowl. Then, in a separate cup, mix 2 parts of sugar
Okay.
with 3 parts of baking soda. Now, get the alcohol and fill the top of the sand with it.
Okay.
Now, pile this mixture and put some more alcohol. Then, light it. But be careful because this may burn you.
Okay.
Now, we will leave this aside and let us talk a little bit about it. We will observe black carbon ashes that will puff up into a continuous strand resembling a snake. The conclusion for this, or why this happened, is because when baking soda burns, it produces carbon dioxide, water, and sodium carbonate. And when sugar burns, it produces carbon dioxide and water. And the carbon dioxide made a snake of carbon ashes. Now, we'll leave this grow, and I have another small bonus experiment.
Okay.
So this experiment is called the slime. Some people in the scientific way call it the gooey creature. So for this, we will need a plate, a spoon.
You can start doing it, Ruqayya, and we will know.
First, we will pour in the amount of glue you want. Now, to make it prettier, we will put some colors and glitter. Now we will put some glitter.
Okay.
And we will mix it.
I like its color.
Now we will put a small pinch of baking soda.
Baking soda and the slime?
Yes. And this will be our activator.
Uh-huh. What's the meaning of activator?
Is the substance that we put to hold it together to form the slime.
Uh-huh.
Now we will mix it.
Okay.
And lastly, for this to pull together, we will put some contact lens solution.
Okay. So the contact lens solution has another use.
Yes. Other than putting it in our eyes. You can see it will start to pull up the plate.
Oh. So this is another way to make a slime.
Yes.
Uh-huh.
Now let's pick this up.
Oh, we have a slime here.
Yes.
Thank you, Ruqayya. I like it. I
So-
like its color.
So here's the slime.
Uh-huh.
Right now, we observed that when we mix the glue, the baking soda, and the contact lens solution, it made us this slime. So this, a lot of you may ask me, is slime a solid or a liquid? Actually, slime is classified as a non-Newtonian fluid, which means that it flows with you according to how much pressure and force you apply to it, and also with the temperature. However, if you touch it softly, as you can see, your hands can pass easily through it. But if you touch it harshly, your hands wouldn't be that easy to pass through it.
Okay.
So now you may touch it if you want.
Yes. Oh, sticky.
Now let's come back to our black snake.
We can see that it's growing.
As you can see, it already the fire started to stop because it's starting to use all the alcohol that we added. So as you can see, here is the black snake.
Okay, amazing.
Now you can see that it didn't grow that much out of the bowl because the other ones that you see growing so much are sometimes really dangerous because they use sulfuric acid. So that's why this is just a small experiment of the big one.
So this is another recipe for the black snake.
Yes,
there is another one?
But it's much safer.
Yes, this is much safer. I think that. So thank you, Ruqayya. Good job, and I'm very. So we're going back to Sajjad to see what happened to the steel wool.
First, we will just remove the steel wool from the vinegar.
Okay.
And we will add it to the second beaker.
Okay.
Then, we will get the tape. And add it around the beaker. Then we will need a paper lid so we can cover the heat inside the beaker from the steel wool.
Okay.
Then we will get the thermometer and we will make a small hole so we can measure the heat inside the second beaker. And we will wait for around 2 minutes.
We can see here the temperature is rising up as it reaches right now 35. So the steel wool is hot.
Yeah, and also if you notice that the beaker got foggy and the temperature rised, and if we get it out, it will form rusting.
Yes, we can see that the beaker is coming foggy.
Yeah, that's called rusting or oxidation because the protective coating of the steel wool is removed because of the vinegar, so it just made rust.
So this is a chemical reaction?
Yes, exothermic reaction.
Thank you, Sajjad. Thank you. So now, yes, we have finished our experiments. And thank you, Sixi. I'm very proud of you. Thank you very much.
Ali is back and he's going to ask you a couple of questions.
Okay, to start with our first question, what is the only food that doesn't spoil or get ruined? If you know, raise your hand.
If you don't know, you can give them choices. What is the only food that doesn't get spoiled? It can stay good forever.
Answer.
Do you have an answer? Go with the mic.
Honey. That's right.
Excellent. Give her a gift. Ali, can you tell them why honey is the only food that doesn't get ruined?
Okay, honey doesn't get ruined because it has a very low moisture content, which prevents bacterial growth.
Bacterial growth.
Bacterial
So it doesn't have water, that's why it prevents bacterial growth. Okay, second question.
Okay, for our second question, at what age do humans start to dream when they're sleeping? Once they are born, or from 3 to 4
1 minute,
years
Ali,
old?
the question again. At what age do humans start to dream when they're sleeping? When do we start to dream? What are the choices?
Once they are born,
Once they are born,
or for 3 to 4 or years old,
or when 3 to 4 years old,
or 7 to 8 years old.
or from 7 to 8 years old. Someone's raising their hand.
Once they are born? I guess that is the wrong answer.
So someone can try again. Go ahead.
3 to 4.
Right.
Okay, excellent. Well done.
You're welcome.
You want to say why? Why is it when they start from 3 to 4 years old?
It is 3 to 4 years old because the age when a child's brain is more developed.
So they need, once they're born, the brain is not developed yet, so they're not able to dream. Thank you, Ali. Thank you so much.
Good morning. So how are you? All of you, how are you? You guys, I can hear your voice louder inside the class. Okay, so we will start with Omar. No, what? No. So, what are we going to do today?
Volcanoes Pepsi.
I can't hear. Your voice is louder in that class.
Volcanoes Pepsi.
Oh. So, can you show us?
ممكن.
Can you bring the
ما فيهاش حاجة.
الكيس؟
بس ما باين شكله وحش.
مش ماشي. شوف نحط الكيس على الديسك.
أنا معايا حاجة صغيرة كده. أروح أجيبها؟
ايه حاجة صغيرة؟
زي فوطة كده.
منفس الجم.
وقع. لا ده هو اللي بيع مش عارف ليه.
ده انا جايبها معايا. على فكرة هو مصطفى اساسا.
We'll open this.
As fast as we can, Miss Nada, okay?
What will you do?
I will put the baking soda on the Pepsi.
Okay.
ايه ده؟ انا بقى منين؟
Oh, so what is this, Omar?
Volcano.
Oh, volcano. So effervescence happens and it flows up from the bottom. Okay, thank you, Omar. Hi.
Hi.
So what do we have today?
Yeah, I wipe both. But first I want to say something. Before introducing my model, I want to very big thanks for the science department for their big effort for they to learn us and instate our knowledge.
Thank you.
My experiment is my model is DI boat. We need foam and we need.
So can you just tell us how it works?
It works that I will gonna like this. That the motor will gonna make it because it's a very big one.
Okay, we can see it. So the motor causes it to
move. It pushes the air to make it push in this the opposite the direction of the fan.
So the direction of the fan is at the back.
Like this. So at the back, so make it.
It makes the boat moves forward.
Yes.
Thank you. It's very amazing. Thank you, Minur. I like it very much. And I want to thank you for your effort, and I want to thank you for all your attempts that doesn't work. Thank you.
Oh.
Hi.
Hi.
How are you?
Fine.
So what do we have today?
I will have a red cabbage experiment.
Uh-huh.
I'll put cabbage water in each cup. I'll put vinegar.
So can you show us?
Yes.
Enough. It's enough. تحط كتير عشان ما
Okay.
Okay.
I will put vinegar. Okay. And let's turn with red.
It turns red.
Yes. And I will put Clinic of Dandruff.
Okay.
Oh.
At least. You need to put a little more. Yes. Okay. So thank you.
Welcome. And I will put lemon juice.
This is what?
Lemon juice. And it's turned to red. Okay. And I will put bicarbonate.
What's the last one?
Bicarbonate.
Okay. So the bicarbonate turns green?
Yes.
Why? Which of them is considered to be an acid and which is a base?
This is acid.
Yes.
And this is base.
And the bicarbonate solution is considered to be a base. Okay, thank you. Thank you, Mary. So hi, Nivel. What do you have today?
Lava in a lamp.
Okay, can you show us?
Okay. First thing we put the food color. Shake it. Then we will put the oil.
So you're adding oil?
Yeah. And then I will put a salt. And then let's make some bubbles.
So it makes bubbles. Oh yeah, we can see it. Here are some bubbles and we can see it. Thank you. Thank you, Nivel. Hi.
Hi.
How are you?
Fine, thank you.
So what do we have today?
Today we have crystallization. My experiment is crystallization. The tools are...
You can explain it.
I don't have. Okay. يعني say the steps على طول. Okay, first thing, we will put some water in a flask and heat it because but we don't have a heater now, so we
Yes, I know, we can show it after and before.
Yes. And we will put some sodium acetate.
So this is not salt?
No, it's a salt, but its type is sodium acetate. We will stir it gently. Then when we see the sodium acetate crystals dissolving in water, we will take it out of the heater. And we will let it cool for maybe 2 hours.
So do you have a sample when it cools?
Yes, here is it.
Oh, it looks like water.
Yeah, it looks like normal water, but
But it contains sodium acetate. Okay.
Okay. Here I will put a crystal of sodium acetate.
You put a small crystal. Of
Yes.
sodium acetate.
And then I will pour our solution. It will take much time, so I have the result here.
Oh, you have the result here when you put sodium acetate crystals.
Yes. When it cool, it will be like this.
Uh-huh.
Yes. Our conclusion is because of sodium acetate is a weak acid, and the water with the sodium acetate dissolved in it is a strong base. When they are combined together, they form salt and water, but in their solid form, not in their liquid form. Just this.
So can you show us the solid form?
Solid form, but it's in the water.
Oh, it's down. It's crystallized down. So what if you put some sodium acetate in this jar? Will it do something or not?
No,
not now. It takes time.
Yeah, it takes time.
Okay, thank you.
Finally, I want to thank all our science department because of their effort learning us to become better. We decided before to come here to thank all of us to thank it, so we will find some words repeated.
Thank you. Sagid, how are you? What do we have today?
Lava lamp.
Show us.
Okay, first step, we're gonna get 1 cup and fill it with oil. And then the second step, we'll get vinegar and put it in the second cup for just a little. And we'll put it for the first cup. And then we'll mix it. Then for the second cup, we'll get water and baking soda. And we'll mix it. And now we'll put the second cup in the first cup.
So it will make a reaction?
Yes.
Okay.
Coloring.
So it can make colors with the bubbles?
Yes.
Okay. Thank you, Sagid. Thank you for your effort. Thank you very much. Good job. Thank you. Yasmin, how are you? So what do we have today?
I have a volcano experiment. The tools is the volcano.
You can explain.
Okay, first we have to put baking soda, like 2 spoons. Then we have colored vinegar. We put it in the volcano slowly.
Oh, the eruption takes place.
Yes.
Okay, thank you. So this is a chemical reaction?
Yes.
Okay, thank you. And what is the gas that comes out?
Is carbon dioxide.
Okay, thank you. Thank you, Yasmin. Good job. Ziad, how are you?
Fine,
So what is our experiment today?
The elephant toothpaste.
Oh, so can you show us?
The tools are.
Can you do the steps?
Yes. First, put some hydrogen peroxide in the bottle. Then put some.
Does the hydrogen peroxide its color is red?
No, we add food coloring.
Okay.
We put the dish soap, then the food coloring, and the final step, we have to put the potassium iodide.
So we can see it growing inside the bottle. I think it will take some time. It will take time?
Yes.
So can we skip and come back to see it? Thank you. But it's growing. Hi.
Hi.
So what do we have today?
Before I introduce my experiment, I have a huge thank for Miss Nada and Miss Riham and Miss Sarah for the huge effort that they made this.
Thank you. Thank you. It's our honor.
We have a growing crystal experiment. We need borax and we will put some boiling water and food coloring here. And we'll put borax. And stir it. And then we'll get this thread and tie it here and put it. And left it for 6 to 7 hours. And it will grow crystal like this.
Oh, this crystal, you do it?
Yes.
Oh, it's amazing. Oh, I like it. So we can use it to do... No, thank you. We can use it to do some jewelry, some necklace, and so on. Oh, thank you. Thank you so much. Hi.
Hi.
How are you?
Fine.
Oh, so what do you have today?
Chromatography.
Chromatography. What do you know? What is this?
Yes, the color on the filter paper split into two colors, the main colors.
Oh, so can you show us?
Yes. We made a line on the filter paper with the pencil and the ruler, and then we make it with the full master color, except the red and the blue and the yellow.
So you do it with green?
Yes. And I put it in the water, and it split into two colors, yellow and blue.
So we can see it here. The color, he made a line with a green full mustard, and it splits into two colors. Oh, we can see the elephant toothpaste of Ziad. It's growing and it looks amazing. Thank you, Ziad. It looks amazing. Good job. I like it. So sorry for the interruption. So you said that the color here is split into two colors, the blue one and the yellow one.
Yes.
Can you know why?
Because the water grabbed the green color from the filter paper and split it.
Thank you. Thank you, Abdurrahman. Good job. Thank you. Razan, how are you?
Fine.
What do you have today?
Rising water.
So can you show us?
First you're gonna add the water, then you're gonna add the food coloring, and you're gonna place the candle in the middle.
Raise your voice, I can't hear you.
You're gonna add water, then food coloring, and you're gonna place the candle in the middle, and you have to light the candle. Then you're gonna put the glass above the candle, and then it will, and then the candle will blow out.
The candle will blow out?
Take some time.
Oh, and what happened to the water surface?
The air decreases and the water rises.
The water rises inside the cup. So thank you, Razan. Thank you so much. Oh, how are you?
Fine, thank you.
So what do you have for us today?
Air pressure can crush.
No, again, can't you?
Air pressure can crush.
Oh, so what is this?
I'm going to let this can crush without using my hands. I will use.
So you are going to crush a can without using your hands?
Yes.
So how can you do it?
First, I will pour the cold water in the bowl. And then I will use the and then I will use the tongs to lift up the
can
from the heat.
دخلك من جوه؟ لا 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 افتح كده بس النص ايوه امسك جامد.
Then I will lift it upside down.
Oh, so it crashed. Here we can see it because it's too hot. The can crashed without using his hands. What happened?
Because the origin when it is heated, the water vapor pushes the original air out of the can, and then the mouth, when I lift it, it forms an the airtight seal against the water bowl, and when it's heated, all of the gas went out, and there was 1 or 2 drops, and these small condensed water are not exerted much for this much pressure.
Thank you, Ahmed. I like it. Thank you.
Good morning. Good morning.
Good morning. Hi.
So our project today is the solar system model, which we made as the pipes are representing the gravity, and the
pipes are presenting what?
Gravity.
Gravity.
Yeah. And the slide bulb is presenting the sun.
So this is the sun.
Yeah.
Okay.
In the middle.
Okay.
It is the source of light. The sun is the source of light and source also of heat, but we didn't made it get heat out because it may damage our product. And at the same time,
this symbol rotates.
It rotates?
Yeah.
Really?
Because we have these T shapes. It makes them rotate. And
can it
also
light?
Lights up, yeah.
Oh.
We can light it up using the light bulb and the light bulb switch and some wires.
By the wires. We light it up by the wires connected to the lamp bulb. Yes, and we can control when it's open and when it's closed by the switch.
And so I can see that they are not on the same level.
Yes, because in real life, actually, not all the planets are in the same level. That's why we had to do each one with a different space, but not very much. Yeah.
Okay, thank you. I like it so much. Thank you.
Thank you. We also would like to thank the science department, and special thank you to Mr. Sharif.
That's me, myself. I would like to thank Mr. Sharif. I don't know why it is him, but I like to thank him. Hi. So what do you have today?
Electric lamp.
So what did you do?
I will get the paper like this. I will cut it, and I will get the glue gun. I put the glue gun here, and I stick this. Then I can get paper and do it like heart or any shape, and put it like this, and put this here. Put this in a lamp, and you can turn it on or off if you need.
So you do a simple electric lamp?
Yes.
Okay, thank you. I like it. Thank you. Hi. I can see that you didn't tie your hair. Yes, I can see it. Yes. So how are you?
Fine, thank you.
So what do you have today?
Whoosh rocket.
Oh, what is this?
It's a bottle that you make it moves by the fire like a rocket.
Oh, so can you show us?
Yes, first you're going to use alcohol and an empty bottle. You're going to pour some of your alcohol in a container. Then you're going to shake it. Then we're going to pour dust. Yes, we're going to pour the rest.
So you remove the alcohol from the bottle?
Yes. Then we're going to need lightning match.
Thank you. Thank you so much, Joan. Thank you. So 6D, I'm very proud of you. Thank you for all your projects. Thank you, all of you. And I'm gonna miss you all.
Good morning, everybody. My name is Fayrouz, and I will ask a couple of questions to you. Deal? Deal. My first question. Which vegetable contains the highest amount of vitamin C? Your choices will be cucumbers, carrots, green and red peppers. Can somebody please answer? Can please somebody answer?
Say the question again slowly, Fayrouz.
The question will be, which vegetable contains the highest amount of vitamin C? Cucumbers, carrots, or green and red peppers?
Go.
Green and red peppers. Correct. You are correct because the green and red peppers 80.4 milligrams and 100 grams.
They contain actually more vitamin C than what?
Vitamin C than lemon and orange.
Yes.
Here you go, your present. You're welcome. For my next question. Wait, okay. Which country celebrates Christmas in summer? Is it Malaysia, New Zealand, or China?
Go.
New Zealand.
New Zealand is the correct answer.
New Zealand.
It actually celebrates 2 times in Christmas, one for winter and one for summer.
Thank you.
You're welcome.
Thank you, Fayrouz. Through different phases. And each phase helped them acquire essential life skills such as research skills, problem solving through trial and error, they didn't all work at the first time, and of course, presentation skills that we saw today. For some, it was really hard work, especially the trial and error part. However, that hard work will pay off, and tomorrow they will see how this experience helped in shaping their character. However, let's be serious, our students will not have the patience to wait for tomorrow to see the fruit of their hard work. So today, it's time now for the distribution of the awards. Starting with 6A.
أحمد حسام الدين. أحمد. علي أيمن. إنجي محمد. جانا محمد. كريم أحمد. مرام عصام. مازن خالد. نور محمود. نور تامر. عمر علي. عمران. سهى. يوسف أحمد. يوسف محمد. يوسف حجازي.
And the best project in 6A, it was chosen according to its uniqueness and originality, and it goes for Noor Tamer, the fan.
Then class 6B.
أدهم. أنس. فاطمة. فيروز. هادية. جودي. ملك. مريم وليد. مايا عصام. محمد حميدو. محمد مبروك. سما سامح. يامن عبد الغني. يامن شاهين. At the end, Zina.
And again, the top projects or experiments were chosen based on their uniqueness and originality, while others were chosen for the excellence in performance and presentation. In 6B, we have the AAC by Yemen Shaheen. The Plastic from Milk by Fairuz Hani. And finally, the DNA extraction by Hadia Mahmoud.
All of you did a great work, Yam.
class 6C, Adam. آلاء. علي. عمرو. فارس. ملك. مروان. مازن. منى. محمد. رقية. سجا. سلمى. سندس. ياسين. يوسف. and Zainab. Thank you all, guys.
The first project that wins for the most original idea is the non-Newtonian float by Selma. Well done. The following two best places are for an awesome presentation and great and excellent knowledge of scientific concept. Malak and Marwan for their pH indicator. Malak and Marwan, come over. And finally, Ruqayya Mabrook for slime and black snake. Well done.
عبد الرحمن سعيد. أحمد كريم. جانا ياسر. جوان. جواريا. جواريا. مهنور. ماريو. ملهم. ناتالي. نور. عمر. فريهان. بيتر. رزان. ساجد. ياسمين. زينة. زياد. النفال.
It was really tough to choose best projects from this class. I just have to say. We've seen so many elephant toothpastes in grade 6 and 7, but I must say that the best one was in this class by Ziad. Well done, Ziad. Next best project is the solar system model by Joerea, Natalie, and Perihan. Then we have the boat made by Mahanur, and I want to give Mahanur a special thank you because she tried 3 projects, she built them, they didn't work, but she kept persisting until the last one worked. And I want you to keep trying working on the free energy one. We'll make it work, okay? Finally, we have the sodium acetate crystals by Zaina Ahmed. And a special thank you to Ahmed for your unique idea. Come over, Ahmed. Finally, on behalf of the science staff, Mr. Sharif, Ms. Iman, Ms. Nada, and Ms. Riham, I would like to thank you all for joining us today. Also, I would like to thank all members of the middle department for their support in organizing the day. Thank you very much. And a special thank you is due to our head of department, Ms. Marwa, for her constant support and guidance. Thank you, everyone. Have an amazing summer.